In this video, we're going to discuss reactions involving gases, and this is going to build on some knowledge you learned in Chapter 4. So, understanding reaction stoichiometry can aid in understanding gas reactions. Now, often when we're reacting gases, instead of giving the amount in moles, we give it as a volume. But we can use the ideal gas law to convert from volume to moles, or if we're at standard temperature and pressure, we can easily use the volume of a gas at STP, which is 22.4 liters. And then we can convert from moles of one reactant to moles of a product, and then over to the volume of the product if it is also a gas. For instance, how many grams of water form when 1.24 liters of hydrogen react completely with oxygen at standard temperature and pressure? So here, since we're at standard temperature and pressure, we can just use our molar volume of a gas. So we know 1.24 liters hydrogen. We know that 1 mole of hydrogen is 22.4 liters. We know from our balanced equation that 2 moles of hydrogen react to form 2 moles of water. And then we know the molar mass of water. So 1 mole of water weighs 18.02 grams. That's just its molar mass. And we can multiply all of that out and get our answer. And we get a mass of 0.998 grams of water. And there's the whole thing worked out again. Here's where you can pause the video and practice on your own and then see how that went. What volume of oxygen at 0.750 atmospheres and 313 Kelvin is generated by the thermolysis of 10 grams of mercury oxide? So we know we have 10 grams of HGO, which is a solid. We are given in the question the molar mass, 216.59 grams is 1 mole HGO. We know from our balanced equation that 2 moles of HGO make 1 mole of oxygen. So we can multiply that all out and then find our moles of oxygen. So I get an answer of 2.309 times 10 to the minus 2. That's my moles. Here I am given that my pressure is 0.750 atmospheres. I'm looking for my volume. My moles, I now know, is 2.309 times 10 to the minus 2. R, as always, is 0.08206. And then my temperature is 313 Kelvin. So I can solve for my volume. And I get a volume of 0.791 liters. One more for you to practice on. What mass of water vapor is produced from the gas phase reaction of oxygen with hydrogen in a 2.5 liter container at 28 degrees Celsius if the partial pressures of oxygen and hydrogen Our oxygen is 0.98 atmospheres and hydrogen is 1.24 atmospheres. So here we are pulling together several concepts. We want to know our mass of water vapor. We are given two partial pressures, which means we also have to figure out what our limiting reactant is. There are a couple ways you can do this. What I'm going to do is I'm going to solve for the total number of moles and then use my mole fractions use my partial pressure fractions really to get my number of moles of each substance. So I know that my total pressure is 0.98 plus 1.24, which is 2.22 atmospheres. My volume is 2.5 liters. I'm looking for moles. My temperature is 301 Kelvin. So I can solve for my total number of moles, and I get a total number of moles of 0.2247 moles. And I know, so my moles of oxygen are going to be 0.98 divided by my total pressure, 2.22, times my total number of moles, 0.2247, which gets me 0.009919 moles. And my number of moles of hydrogen is going to be times 0.2247 gets me 0.1255 moles of hydrogen. All right, and I have one too many zeros in here. It's just 0.09919. So there I have my moles. Now I have to figure out what is my limiting reactant. So I can do that by dividing each of my numbers by its coefficient. So there's my moles of oxygen divided by 1. This I'm going to divide by 2, which gets me a 0.0627, which means this is what limits me. And then it's asking for mass of water vapor. So I can take my moles of hydrogen times 2 moles hydrogen gets me 2 moles water times my molar mass of water is 18.02 grams. Should get me my answer. And I got 2.26, which is close to 2.25. So the answer is B, which is correct.